Right, good morning. Here's your starter today. So your starters, 2 exam questions, or part exam questions. So give yourself quite a bit of time to do this starter. So question 1 is using product rule, then chain rule, then quotient rule. I've given you the quotient rule in the form that you'll have it in the exam. And question 2, you've got quotient rule, and then you're finding the equation of the normal. So a lot of these A2 differentiation questions are, the only new skill is the differentiation skill. So once you've differentiated this and found the gradient of the normal, then it's exactly the same as you were doing in year 12. Just note that you're going to lose marks if you don't write the equation in the form that it's given. So give yourself a bit of time. So that's 13 marks in an exam. So if you think, a minute, 1.2 minutes. So if you multiply 13 by 1.2, that would be the time that you would have in an exam to complete that. So you're looking at around 16, 17 minutes to get that done. Right, here are your solutions. So question 1, question 2, question 3, and 2 forms for that first part there. And then the big question 2, you can see how that's given. Now, in your new A-level, because it says find, that means that you could, in theory, differentiate. You could differentiate this on your calculator, because you could put that in your calc to find dy dx and substituting x equals 1 in. Now, it's unlikely that it's going to say that in your new A-level. If it says determine, or if the question says show detailed reasoning, you will have to clearly show using the quotient rule. So do be mindful. If it does, however, like this question, say find, in theory, you can just put that into your calculator. This is an old exam question, which is why it says find, and then they're expecting to use the quotient rule. Right, what we're looking at today, explicit. So here we have y equals 3x plus 2. Now that we would say is an explicit, y is expressed explicitly here. It's an explicit equation. However, here, 3x plus y equals 2, this is implicit, where you don't clearly have one variable as the subject. Of course, using your maths, you could change that, but sometimes you can't. So what we're going to look at today is we're going to differentiate some implicit equations. So if you can just have a little look at the lesson so far. So here, this first example, you can see that here I have an equation expressed explicitly, but I'm able to write, here we have an equation expressed implicitly, but I'm able to express it explicitly, so I'm finding it easy to find my gradient. Now you would, other than the dy dx, you would have done that at GCSE in the whole y equals mx plus c thing. However, here we now have an example of an equation expressed implicitly that is much more challenging to express explicitly. So I've got an equation of a circle here, center 2, 3, radius 4. I'm going to try and make y the subject. It isn't great, because obviously I'm taking the positive and negative square root, and you know from what a circle looks like how complicated it is. So I've got that. Now I don't want to differentiate that, especially with the whole plus minus thing. So it can't be written in this nice explicit form easily to get the gradient. So we're going to need another method. We're going to need another method to find gradients of equations that we can't write in explicit form. So what we're going to do is we're going to look at the chain rule. So remember the chain rule. Now the chain rule uses this idea of like a cancelling. So remember we have this idea. I mean, it's not great maths, but it works for us. It's like cancelling of fractions. So we know that dy dt times dt dx is dy dx. And sometimes when we differentiate things, if I want to differentiate something with respect to x, I can, if I want to, write it like this. This means I'm going to differentiate 3x squared with respect to x. This means I'm going to differentiate 5x squared plus 3x minus 2 with respect to x. This means I'm going to differentiate, well, cos x with respect to x. So all I'm going to do is mix these two ideas up together. Okay, differentiate 3y with respect to x. Now, at the moment, you don't know how to do that. But hopefully, using those two ideas, we're going to be able to do it. I can only differentiate this with respect to y. So that's what I do. So what I'm going to do is I differentiate the 3y. First of all, it might have been better if I'd sort of unveiled it like that. First of all, I differentiate the 3y with respect to y, which I know I can do. It's just 3. It's not what I've been asked to do. And then I multiply by dy dx. If I differentiate 3y with respect to y, I get 3. Multiply by dy dx to get this overall effect of cancelling. And I've ended up with 3 dy dx. I'm now going to differentiate 4y squared with respect to x. So I do exactly the same. I differentiate with respect to y, which I know I can do. It's just going to be 8y. And then I multiply by dy dx, and I get this overall effect of the dy's cancelling. So d 4y squared dx. But I can physically do it. So I've like added these dy steps in to make it work. So my answer is 8y dy dx. Okay, so when we differentiate an implicit equation, you differentiate each term individually. Differentiating x terms, absolutely fine. However, to differentiate a function of y with respect to x, that's what that little abbreviation there means, you first of all differentiate it with respect to y and then multiply by dy dx. So let's have a little look here. We're going to differentiate this equation with respect to x. So quite a lot. So first of all, 3x squared, fine. Now, we're going to differentiate this first with respect to y, which is minus 4y, and then we multiply it by dy dx. Now, let's differentiate the 4x. That's fine, that's just 4. But now it's a y term. So you differentiate with respect to y, which is minus 5, and then you multiply by dy dx. And the thing people sometimes forget to do is then differentiate their constant. So now you've done the hard work. You're now going to get your dy dx terms on one side and your non-dy dx terms on the other side. You're going to make dy dx the subject. Now I've moved those over there because I'm mindful of keeping everything positive. Take out a factor of dy dx and then divide both sides by 5 plus 4y, and that is your answer. A gradient given in terms of x and y for the first time that you've ever done that. Right, pause the video, differentiate those just like I've just done. Okay, so your answer to the first one, you could have this equivalent where top and bottom are multiplied by -1. So you could have had minus 2x minus 3 all over 5 minus 4y. And here's the second one. So again, you could have had minus 15x squared over 6y minus 2. But I'm trying to keep it as nice as possible. Right, example 2. Find the gradient of the curve x squared plus y squared, that's off your circle, equals 25 at this point here. So differentiate. So this bit's taken from the textbook, so you can see they're going nice and steadily. They differentiate everything with respect to x. So the x squared becomes 2x. The y term you differentiate with respect to y, and then times by dy dx equals 0. Okay, so I've then taken the 2x over there to become minus 2x. I'm now going to divide both sides by 2y. So I end up with dy dx is minus x over y. I'm now going to substitute my point in, 3, 4. And we're home and dry. Dy dx is minus 3/4. Example 3, bit of trig. Find the gradient of this curve. So, first of all, differentiate. Not good. So I think I've changed this, and now the signs aren't correct, are they? That was correct. I'm so sorry. Pretend that never happened. Right. Let's differentiate. So first of all, differentiate cos x with respect to x minus sine x. Sine y. Differentiate with respect to y, that's cos y, times by dy dx equals 0. You're now going to make dy dx the subject. So if you take the sine x over to this side, you'll get cos y dy dx equals sine x, and then divide both sides by cos y. So that is the idea of implicit differentiation. Okay, and now the questions. So plenty of practice before we move on tomorrow to make this a bit harder. So question 1, question 2. So your questions are on your PDF. Now there's a nasty question, the extension. I've given you some nice hints in orange. Take your time, email your teachers if you find these challenging. And here are your solutions. See you tomorrow.